Hello, Cardinals. It's Tuesday, October 25th, and we are on page 45 in our assignment notebook, or in our interactive notebook. We are doing investigation 4.1, observing the motion of a car. We're going to get steps 1 and 2 done today, focusing on the question, how do we use Newton's laws to predict motion? Before we get going today, we have some vocabulary to get in our notebooks on page 43. That's where your vocab for lesson 4 goes. Balanced forces should be written down. Those are forces on an object that are net zero. Unbalanced forces are forces of an object that aren't net zero, and inertia is the ease at which an object can change motion. So when you're talking about balanced forces, a lot of times there'll be 2 or 3, maybe even 4. As long as all the forces add up to be 0, the object doesn't move. The forces are said to be balanced. Unbalanced forces are when those forces on an object are not 0. So if you're pushing with a large force from the left and a small force from the right, that would be unbalanced and that would cause the object to move. And finally, inertia. The best way I can explain inertia is you wonder why offensive linemen in the NFL are 320 pounds and getting bigger all the time. It's because offensive linemen their job is to not move, is to absorb the impact from the defense. A offensive lineman has a large amount of inertia, which is the ease at which an object can move. The larger an object is, the more difficult it is to move that object. We also have Newton's laws of motion, which describe the effect of balanced and unbalanced forces on an object. And going over this, unbalanced forces and balanced forces are what Newton's first law is all about. Balanced forces are no change to an object's motion. Unbalanced forces cause change in speed or direction. So that's Newton's first law. An object at rest will stay at rest unless acted upon by an unbalanced force. Well, basically it says, as long as no force is changing, the forces are balanced, there's going to be no change. And you should probably draw these. These are in your book that you read yesterday in the Newton's laws of motion reading. But as you look at this, balanced forces, if an object is at rest, shows objects pushing at the same from both sides, that object would remain at rest. If that object was in motion and there's still the same amount of force on both sides, that object would stay in motion. Okay, it would stay moving in the same direction. If it's unbalanced, like let's say there's a large force pushing from the left and a small force pushing from the right, that would cause that object to begin to move or accelerate. And then finally, if it's already moving and there's a large force that's going to move faster, or if it encounters something like a hill, then that's going to cause that motion to change also. Newton's second law is acceleration of an object is equal to the net force of the object divided by the mass. So it's a little bit of an equation here. Acceleration equals force divided by mass. And the way you can see this is if you have the same amount of mass, you have 5 kilogram objects here. If it's a large force, it's going to accelerate with a large amount. If it's a small force, it will accelerate with a small amount. The same is true with mass. If the same force is being applied to a large object versus a small object, the large object will accelerate less and the small object will accelerate more. And you know this. You know that if you threw a bowling ball, it's not going to go as far as if you threw a tennis ball. And that all has to do with the mass of objects. This is a little visual. You do not have to write this down, but the more force there is, if the mass stays the same, the more acceleration. So it's kind of taking those pictures we had and making them into a chart. So from yesterday, we did this in our science notebook after the quiz. You should have completed illustrations of forces for an arch, pushing an automobile, pushing a bicycle, and a baseball bat versus a ball, which is different than a bunt motion versus a ball. So all of this should be in your notebook from yesterday. And what we're going to do is you're going to get into groups, and you're going to share your force drawings from yesterday with your table group. So you're going to talk about those with your groups, go around and show everybody what you drew. And then you're going to critique and evaluate how the size and direction of each arrow, how that represents force in this situation. How does that represent, a push or a pull on an object? Once you've decided on some accurate representations, you can use markers, which are in the back of the room, and the guest teacher can get those for you. you're going to draw some force diagrams on a large sheet of paper. You're going to do a really good job because you're going to be turning these in at the end of the hour, and they're going to be, hopefully displayed around the room in the hallways. So make sure to explain in writing what your thinking is behind each force diagram with your class. So there's 3 situations we just talked about, and those situations need to be placed on your large sheet of paper and drawing with markers and explaining. If you get time, you want to go through this. This is the stone arch, this little example, an automobile and a bicycle and a bunt. So this is how far we're going to get today. There's also an exit card to do at the end of class. We're going to be picking up with investigation 4.1, step 3 tomorrow. That would be on Wednesday. So you need to get through investigation 4.1, steps 1 and 2 with the guest teacher on Tuesday, and we'll pick up with step 3 on Wednesday. Hopefully you had a great day, Cardinals, and enjoy your day.